Hello, this is Dr. Zach. So for today's review, you're going to practice Rolle's theorem and the mean value theorem, as well as a few more derivatives. All right, let's get started. For today's lesson preview, you were asked to think about the mean value theorem. Big idea. The slope of your secant line is equal to the slope of the tangent line at least once if your function is continuous and differentiable over your closed interval. Now, did you notice that this interval only went from -3 to -1/2? So that should eliminate at least one of your possible answers. So as a reminder, Rolle's theorem, there are three conditions that must be held in order for the conclusion to be true. F of x must be continuous, it must be differentiable, and f at a must equal f at b on that closed interval ab. If these three conditions are true, then there must be at least one number c for which the derivative is equal to 0. And then Rolle's theorem gets extended into the mean value theorem, so f is continuous and differentiable. If this is true on a closed interval, then there exists at least one number c on AB such that the derivative is equal to the slope between your 2 points. All right, so now we're going to look at example 1. To determine whether the function satisfies the conditions of Rolle's theorem, we should think about each condition. What is f of 0? And what is f of 2 pi? Check to see that they are equivalent. As you know, these are both equal to 0 when f of x is equal to the sine of x over 2. Now, since we have a trig function, the sine of x over 2, we know that f of x is continuous on 0 to 2 pi. We also know that f of x is differentiable on 0 to 2 pi as well. Matter of fact, f prime of x is equal to 1/2 cosine x over 2. So we're going to use that to determine where our hypothesis is going to occur. We know that f prime of x must equal 0 somewhere on our interval 0 to 2 pi. We don't include the endpoints. So when we set our derivative equal to 0, we know that x over 2 is equal to pi over 2. We know that x over 2 is also equal to 3 pi over 2. Of course, there are infinitely many places where this will occur. Unfortunately, we're only interested in what happens between 0 and 2 pi. So we're going to cross out x equals 3 pi. So what do we know? Rolle's theorem guarantees that somewhere along the way, the derivative f prime of pi is going to be equal to 0 on our interval 0 to pi. So Rolle's theorem guarantees this. All right, now let's take a look at example 2. For example 2, we want to find all c on the interval 2, 8 that satisfies the mean value theorem. So we're not really concerned about the endpoints this time as part of our hypothesis. But let's think about f of x. F of x is continuous on 2, 8. It does have a discontinuity at 0, but that's not on our interval, so it is fine. F prime of x is going to be equal to 32 over x cubed. So we know that f of x is differentiable on 2, 8. All right, so the next thing we want to think about is the conditions for the mean value theorems. Those are complete. What does this tell us? The mean value theorem states that f prime of x is equal to the slope of the secant line on to 8. Now we're asked to find that value. So we know that 32 over x cubed must equal f at 8 minus f at 2 over 8 minus 2. And this happens when 32 over x cubed is equal to 5 over 8, or when x is equal to 256 over 5 to the 1/3 power. So this is the c value, where f prime at 256 over 5 to the 1/3 is equal to 5 over 8. So for today's lesson practice, you're going to practice for your midterm exam. Number 1 is a typo. It should say 2x plus x squared plus 2. And what I'd like you to do is spend the next 20 minutes working on questions numbers 1 through 12. After you've worked for 20 minutes, you can check through some of your answers. All right, so you should have found that question number 1, Rolle's theorem, did not apply. And for question number 2, the mean value theorem did not apply, because for question number 2, you need to have closed intervals to satisfy the mean value theorem. All right, so question number 3, you should have found that Rolle's theorem did not check out, because f of x was not differentiable over the function. Make certain to use limit notation to describe y. Number 4, you are to practice your derivatives, and remember that before you do anything, you should simplify the problem. If you do not simplify the problem, you will not find the correct answer in a multiple choice test. So simplify the equation before you find your derivative. Number 5, you should have found that the value of b was equal to 1. Number 6 took a lot of effort, but make certain that you are using a table of values or the second derivative test to show a min or a max. Number 7, take a look at it for a moment. You should have found that the mean value theorem works, and eventually f prime, the square root of 3, was equal to 9. Make certain that you show that your two conditions, and then state your hypothesis, and afterwards you can find the value for which this is true. Question number 8. You're looking for the derivative of g at 6. So follow through with what we were doing before. Hopefully you came up with the answer is 4. Number 9. Did you come up with? Your answer is C. Number 10. So you are looking for your vertical tangent lines, and notice that you're looking for points. So if you're looking for the vertical tangent line at points, you should have found they were vertically tangent at 0, -2, and 2, -2. There were 2 answers for that. Number 11. Once again, do you remember how to find a derivative of a natural log function? And then you were to substitute in your -1. There was no algebra to do before you could simplify this problem. So you just needed to do the problem and substitute -1. Number 12, you were looking for the difference between the greatest and the smallest values. Your greatest value, when you think about your table, should have had x and f prime of x, because you were looking for the greatest and smallest values of the slope. And 0, 6, and 2 were the numbers you wanted to consider. The critical number being the 2, and your endpoints, of course, were 0 and 6. 0, -36, and 12 should help you find your correct answers. All right, now it's time to study for that midterm. This is your last push for it, your lesson follow-up. You should pick and choose some of the questions from the AP Calculus Review, Units 1 to 6. You do not have to do the entire assignment. Just pick and choose where you need the most practice. All right, you have an excellent day.